On one night in September of 1859, the sky of the entire planet catches fire, from the frozen poles to the tropics. People step outside and believe the dawn has come early, or that a great fire is consuming the far horizon. Some fall to their knees, convinced they are witnessing the final hours of the only world they have ever known. Yet what unfolds that night is not an ending, but a warning that science would need a century to fully decode. The official histories file it away as a curious footnote, a strange evening of colored lights and harmless sparks. What they leave out is far stranger, and far more dangerous to the wired civilization that would follow after. This is the story of the most powerful technological disaster the sun has ever inflicted upon all of humankind. And the deepest question is not whether it will happen again, but how soon, and how ready we truly are for it. To understand that night, we must travel back to a world that has only just learned to speak across great distance. The year is 1859, and a new invention is quietly rewriting the meaning of space, of time, and of human contact. The telegraph has spread across continents, like a nervous system stretched over forests, plains, and open seas. Thin copper wires hum above the rooftops, carrying words faster than any horse or ship in all of human history. For the very first time, a merchant in London can learn a price set in New York within minutes, rather than weeks. News that once took weeks to cross an ocean now arrives almost the moment it happens, and the world holds its breath. Messages now leap beneath the oceans themselves, for the first daring cables already creep along the dark seabed. The pace of life itself begins to quicken, as distance shrinks and the world grows suddenly and dizzyingly small. Newspapers call it a miracle of progress, the binding together of distant nations through pulses of pure energy. Historians today describe this network as the Victorian Internet, the first truly global web of human messages. The telegraph key becomes the heartbeat of commerce, of government, and of news traveling between far cities. Operators learn a new language of clicks and pauses, a coded music that carries human thought along the wires. Empires lean upon these slender lines to govern colonies and armies separated by thousands of restless miles. Cities glow with confidence in the new electrical age, certain that science has finally tamed the unknown forces. To the people of 1859, electricity feels less like a danger and far more like a tame and obedient new servant. In this proud and optimistic world, the heavens above are seen as distant, orderly, and entirely predictable. Few among them suspect that the calm sun overhead is a restless engine capable of reaching across empty space. In England, a wealthy young man turns his private telescope toward that sun with patient and careful devotion. His name is Richard Carrington, an amateur astronomer mapping the dark spots that drift across the face of our star. Carrington works from his own observatory at Red Hill, funded by a family fortune built from brewing and trade. Day after day, he sketches the shifting blemishes, building one of the finest sunspot records of his entire age. He measures the sun's rotation through the patient drift of its spots, a labor demanding rare and quiet discipline. To him, the sun is a puzzle of light and shadow, never a weapon poised silently above the wires of his world. He does not yet know that his quiet hobby is about to place him at the very center of a historic discovery. Across the ocean, and across all of Europe, telegraph operators tap their keys, unaware of what is coming for them. In bustling offices, clerks send orders and lovers send greetings, trusting the wires with their daily lives. The whole of this connected world rests upon a single assumption, that the sky will remain calm and obedient. In the final days of August, something shifts in the rhythm of the sky that the careful watchers begin to notice. Strange auroras flicker at unusual latitudes, painting the night in shimmering colors that should not appear there. Compass needles tremble and wander, as though the Earth itself has grown uncertain of which way is truly north. These are the first faint whispers, the quiet signals that precede the storm now gathering on the face of the sun. A vast cluster of sunspots rotates into view, darker and far larger than anything Carrington has charted before. Through late August, the sunspot group swells, knotted with the tension of magnetic forces no one can yet see. Such regions are storehouses of energy, coiled like springs that have been wound far too tightly to ever hold. For days, the great spot group crackles with unseen activity, a furnace building toward a single violent release. The spot group grows so large that it can be glimpsed with the naked eye, through thin cloud or darkened, smoked glass. On the morning of the 1st of September, he climbs to his observatory, as he has on countless ordinary days. Sunlight passes through his telescope and projects an image of the sun onto a screen for safe and steady study. At 18 minutes past 11, the routine of decades shatters in a single blinding instant of pure white light. 2 points of intense brilliance erupt suddenly within the great dark cluster of spots spread out before him. The flash is so fierce that Carrington first believes a beam of raw sunlight has somehow broken through his lens. He races to summon a witness, but by the time he returns, the violent glow has already begun to fade and vanish. Miles away, another observer named Richard Hodgson sees the very same eruption through his own private instrument. 2 men, working alone and entirely independently, witness the first solar flare ever recorded in human history. What they observe is an explosion releasing energy beyond anything imaginable on the surface of our small planet. When that immense tension finally snaps, the release is sudden, vast, and utterly indifferent to the world below. From the sun's roiling surface, a colossal cloud of charged matter is hurled outward into the cold dark of space. Scientists today call this a coronal mass ejection, 1 billion tons of plasma moving outward at staggering speed. The flash itself carries radiation that crosses the void in 8 minutes, arriving before the slower cloud behind. But it is the trailing wave of particles behind the flash that holds the true menace for the wired Earth ahead. Normally, such a cloud would take 3 or 4 days to cross the vast distance between the sun and the Earth. But an earlier eruption has already swept the path clean, clearing away the solar wind that would slow it down. And so this storm races toward our fragile planet in barely 17 hours, far faster than nature usually allows. Carrington records his careful observation and waits, sensing that he has just seen something extraordinary unfold. He cannot yet know that the invisible payload of that flash is already speeding silently toward his distant home. As the 1st of September gives way to the 2nd, the cloud of charged particles slams into our turning world. It strikes the great magnetic shield that surrounds the planet and sets the entire field ringing like a struck bell. The shield that normally turns such storms aside is overwhelmed, and the energy finds its way down to the ground. Across the globe, the delicate instruments built to measure magnetism swing wildly far beyond their printed limits. Scientists watching their dials see the needles pinned hard against the edges, unable to record the violent surge. Electric currents are induced in the long telegraph wires, currents no engineer of the age has ever anticipated. The energy pouring into the upper atmosphere begins to bleed downward into the wires strung across the nations. In telegraph offices from America to Europe, the patient machines begin to behave as though they are possessed. Operators reach for their familiar keys and feel sharp shocks leap from the metal into their startled fingers. In Washington, an operator receives a powerful shock to the forehead as he leans toward his trembling apparatus. Sparks crackle and arc across the equipment, leaping between contacts meant to carry only the gentlest of currents. In other stations, Men step back from their desks as arcs of light dance between the brass and the iron parts. In some offices, the bright sparks ignite the slips of paper waiting beside the steadily chattering instruments. Small fires flare upon the desks, and operators scramble to smother the flames before they can spread any further. The current, surging through the lines, is not the tame signal of human design, but a wild force born of the sun. Along certain routes, wooden poles smolder and quiet telegraph stations fill with the acrid smell of burning. In Pittsburgh, the currents are reported strong enough to char the wood and damage parts of the delicate machinery. Some lines refuse every command, while others send phantom signals that no human hand has ever touched or sent. The orderly rhythm of the network dissolves into chaos, a din of false clicks and silent, smoking instruments. Across the wires, operators trade astonished messages about the storm, comparing the chaos in their distant offices. They cannot work, yet they cannot look away, witnesses to a force that dwarfs every invention of their proud age. Operators disconnect their batteries, hoping to spare the lines from the relentless flood of this strange energy. And then the most astonishing event of the entire night begins to unfold across the wires of New England itself. On the line between Boston and Portland, two weary operators agree to cut their batteries away completely. With no power source connected at all, the telegraph should fall silent, dead and useless, until the morning comes. Instead, the instruments keep working, humming with a current drawn from the glowing sky stretched out overhead. The auroral storm has turned the very atmosphere into a battery, feeding the long line with celestial power. For hours, the two men send their messages using nothing but the raw energy of the heavens above their heads. It is a moment unlike any in the history of communication, the planet itself whispering through human-made wires. Yet even amid the failures, a strange beauty unfolds, for the lines briefly carry the living pulse of the sky. Above them, the night sky has transformed into something that defies every memory and expectation, then alive. Curtains of crimson and emerald light ripple across the heavens, pulsing with an unearthly and silent kind of fire. Outside, the auroras deepen into sheets of rose and gold and green that climb from the horizon to the very zenith. The Aurora, normally a guarded prize of the frozen poles, blazes openly over Cuba, the Caribbean, and far Hawaii. In Colombia, near the equator, people gaze upward at colors their ancestors had never once thought to describe. In the tropics, where such lights are unknown, frightened crowds gather to watch the sky burn without any flame. Observers in Hawaii, far out in the Pacific, describe the heavens glowing as though lit by a hidden second sun. In Chile and across South America, the unfamiliar lights stir both deep terror and a strange and reverent wonder. The glow is so brilliant that across many lands the night becomes nearly as luminous as the early light of dawn. High in the Rocky Mountains, a camp of gold miners stirs awake, certain that the morning has finally arrived. They rise from their blankets, build up their fire, and begin to cook their breakfast beneath the burning sky. In the gold fields, the false dawn is so convincing that whole camps begin their morning long before midnight. In eastern cities, people step into the streets and read their newspapers easily by the soft light of the aurora. The light is bright enough in many places to read the finest print, as though a strange new moon has risen. Some gather inside their churches, falling to prayer, convinced the heavens are announcing the end of all things. Many interpret the spectacle as an omen, a sign from the heavens that the very order of the world is breaking. Across the American South, people wake their neighbors, certain a distant city must be consumed by a vast fire. Others simply stand in silent wonder, watching colors no living person had ever seen come pouring across the dark. Birds stir and begin to sing in the false brightness. fooled like the miners into believing the morning has broken. Sailors far out at sea record the strange light in their logs, unsure whether to write of fear or pure amazement. Across the great cities of Europe, the same colored fire spills southward into skies that rarely ever see it. In Rome and in Madrid, citizens crowd onto the rooftops, exchanging fearful glances beneath the shimmering heavens. Across the continents and oceans, millions of eyes turn upward on the same night toward the same impossible sky. The whole planet, for a handful of hours, wears the same crown of fire that usually belongs to the poles alone. For a few extraordinary hours, the entire human family shares a single vision, written in fire above their heads. And while they watch in awe, the invisible storm tears silently through the only fragile technology they possess. The storm does not relent quickly, for the magnetic disturbance returns in waves across the long autumn night. Each surge brings fresh sparks and fresh alarm to the offices that have not yet abandoned their silent posts. The Telegraph network, the celebrated pride of the age, lies crippled across 3 separate continents at once. In Europe, lines fall silent or rage out of control, and entire systems must be shut down purely for safety. In North America, operators abandon their posts as the machines spit sparks they can neither understand nor stop. In Australia and across distant Asia, the same eerie failures ripple through every wire touched by the great storm. In London, the great telegraph hub of an empire, operators watch helplessly as their busy lines fall into disorder. The very wires that bind the world together become, for a few hours, conductors for the restless fury of the sun. No defense exists against such a force, for no one in 1859 has ever imagined that the sky could strike the ground. Even as the panic spreads, a quiet marvel takes hold, the sense of standing beneath a sky entirely transformed. Children are lifted to the windows to witness the colors, a memory their families will carry through all their lives. In a single night, humanity learns that its newest creation can be struck down by a force from the open sky above. Yet because the world leans on these wires so lightly, the chaos remains an astonishment rather than a true ruin. For one night, the boundary between the heavens and the works of humankind grows thin and dangerously porous. When the true morning finally comes, the sky settles, the sparks die away, and the wires slowly return to silence. Operators inspect their scorched equipment, sweeping ash from the desks and marveling at what they have survived. Newspapers fill with breathless accounts of the night. The heavens caught fire and the proud telegraph rebelled. Readers across the world devour stories of glowing skies, burning paper, and lines that somehow ran without power. Scientists begin to gather the scattered reports, sensing that something of great importance has truly occurred. The reports gathered from every corner of the globe slowly assemble into the first true portrait of a solar storm. Carrington publishes his careful drawing of the flash, and the world studies the strange image with deep curiosity. For the first time, thinkers begin to connect the violence of the sun directly to the disturbances felt on Earth. A new science is quietly born. On that night, the patient study of how our star reaches across space to touch us. Researchers slowly realize the flash, the magnetic storm, and the failing wires are links in one single great chain. The bond between sun and earth, once a matter only of warmth and light, becomes a question of hidden and vast power. In the years that follow, observers begin to watch the sun with new and far more anxious and careful attention. They learn to track its spots and its storms, slowly building the young science we now call solar physics today. Each later flare is measured against the giant of 1859, the standard by which all solar fury would be weighed. Generations later, The data gathered from that night still guides the scientists who study our restless star. The night teaches a humbling lesson that the star which gives us life can also reach out and disrupt our works. Yet beneath all the wonder lies a sober truth that few people in 1859 are truly prepared to understand or accept. The damage stayed small for one reason alone, and it had almost nothing to do with human skill or with foresight. The world was simply spared because it did not yet lean its full and growing weight upon the electrical current. There are no power grids feeding the cities, no machines running the homes, no vast systems waiting to collapse. The telegraph is still a thin and lonely thread, and when it breaks, ordinary life carries on almost untouched. Had the storm arrived a century later, the story of that night would read instead like a chronicle of catastrophe. And so the event becomes a quiet benchmark, the measuring stick against which every later storm would be judged. Carrington's name attaches itself forever to that night, a permanent marker in the long memory of human science. The Carrington Event passes into legend, half a scientific milestone and half a warning written in the stars above. More than a century and a half later, the world that the storm once spared has changed beyond all recognition. We have built a civilization woven entirely from electricity, threaded through with countless currents and signals. Power grids now span whole continents, carrying energy to billions of homes, hospitals, and humming machines. Satellites drift far above us, silently guiding ships, planes, and the small glowing devices in our own pockets. Banks move vast fortunes as invisible pulses, and a single failure can ripple across the entire planet in seconds. The thin telegraph thread of 1859 has grown into a dense and fragile web that holds all of modern life together. And that delicate web hangs beneath the very same sun that once set the Victorian sky ablaze with silent fire. Our deep reliance on the current is the very thing that transforms a Victorian curiosity into a modern peril. The more tightly we weave our lives into the grid, the more we expose ourselves to the temper of the distant sun. Scientists know with quiet certainty that a storm like Carrington's will inevitably strike the Earth once again. Modern studies warn that a Carrington-class strike is not a question of if, but only ever a question of when. The only uncertain part of that grim promise is the timing, the simple question of which year the blow will land. If such a storm arrived today, the immense surge would pour into power lines stretched across entire nations. The great transformers that anchor our electrical grids could overload and fail far faster than we could repair them. Such a storm could damage transformers, so large and specialized that their replacements take many months to build. Without them, the lights stay dark, and the long and patient chain of recovery stretches across entire seasons. Whole continents might fall into darkness not merely for hours, but potentially for many long and difficult months. Water pumps, refrigeration, heating, and hospitals all depend upon a steady current that could simply vanish. Satellites might be damaged in their orbits, silencing the navigation systems that quietly guide our daily lives. Communications could fracture, leaving cities struggling to coordinate, to inform, and to recover with any speed. The interconnected nature of the grid means a failure in one region can cascade swiftly into many others nearby. Researchers have tried to measure the true cost, and the numbers they reach are genuinely difficult to imagine. One sobering study estimates a severe storm could cost the United States alone up to $2.5 trillion. And this is no distant fantasy, for the sun has already reminded us just how close such a future truly remains. In July of 2012, a storm rivaling the raw power of the Carrington Event erupted from the surface of our own star. A massive cloud of plasma tore through space along the very orbit that our planet travels around the distant sun. By a margin of only about a single week, the Earth had already moved past the point where the Great Storm crossed. Had it left the Sun just a few days earlier, the cloud would have struck our modern, electrified world directly. We did not avoid that disaster through wisdom or careful preparation, but through the pure good fortune of timing. Decades before, in 1989, a far smaller storm offered a brief and deeply unsettling taste of what is now possible. In Quebec, a geomagnetic surge collapsed the power grid, plunging millions into cold darkness within mere minutes. That event lasted only hours, yet it revealed how swiftly our intricate systems can be brought to their very knees. It was a faint echo of 1859, a small rehearsal for a performance that no one truly wishes to ever have to witness. Agencies now watch the sun constantly, hoping to grant us a few precious hours of warning before a cloud arrives. Those hours could allow operators to shield the grids, but only if the systems and the human will are truly ready. And still, much of the world treats the threat as a distant abstraction, a problem reserved for some other day. We have grown so accustomed to the steady current that we mistake mere habit for safety and luck for true control. Our modern grids were never designed with such a storm in mind, for the danger faded as the wires only multiplied. A single severe event could touch the lives of billions at once, in a way the Victorians could scarcely conceive. Each passing year of quiet lulls us a little further, until the memory of the danger dissolves into easy routine. Until that day arrives, the storm of 1859 waits within our history as both a marvel and a patient, silent warning. The sun has not changed since that September night, and it does not forget how to reach across the dark toward us. It will flare again, and one day a cloud of fire will leave its surface, aimed squarely at our crowded blue world. Whether that arrives next year or next century, the wires and grids of our civilization will be waiting for it. The only question that has ever truly mattered is whether we choose to prepare or whether we choose to look away. The open loop of that night finally closes here, in the fragile and glowing world that we have since built around us. A sun that exploded, a global network that collapsed, and a planet that never grasped how near the edge it stood. The warning of 1859 was not erased by the dawn, for it remains written plainly in the physics of our own bright star. What spared the Victorians was not their wisdom, but the simple fact that they had so very little left to truly lose. We have far more to lose, and far less time than comfort would have us believe, beneath that same restless old sun. The lights of 1859 were a message sent across a century, asking a question we have still not answered with honesty. Are we genuinely prepared for the storm we know is coming, or merely comfortable inside our long and easy forgetting? Explore the other great moments when the world stood quietly at the edge of transformation and learned to endure.